Hi, today we're going to continue our discussion on proofs. Yesterday, we talked about theorems, the first 6 theorems. So if you'll take a look at that video from yesterday, that will catch you up, well actually from Tuesday, that will catch you up on that part. Today we're going to talk about the properties of numbers, or at least use those properties of numbers, and those are things that we've instinctively used through various levels of algebra. Well, we're going to incorporate them in geometry proof writing. We have our addition property. Whatever you add to one side, you add to the other, so it remains equal. Our subtraction property. Whatever you subtract from one side, you subtract from the other, remain equal. Same thing for multiplication and division. Then we have our distributive property. We have our transitive property, which may be new to some, which states if A equals B and B equals C, then A equals C. Then we have our substitution property, which simply says if x equals y, then we may substitute in x wherever we see y, or we may be able to substitute in y wherever we see x. Or we have our reflexive property, which states that all numbers or shapes or angles or sides are always equal to themselves. And then we have our symmetric property, which says if A is equal to B, then B is equal to A. Next, we have postulates. And postulates are simply statements that are taken as true. I hope you can see this. I see a glare on here. The first postulate that we're going to cover today is angle addition postulate, which states if we have 2 adjacent angles, we can add them to find the unknown angle. Ms. G, what are you talking about? If B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of AOC. It's simple addition. Add one angle to the other angle that's beside it, and those together will give you the larger measurement of those angles. Then we have the segment addition postulate, which states if we're given 2 points on a line segment, A and C, and then a third point lies on that line segment, then the distance between those points satisfies this equation. Point A to point B plus point B to point C is going to equal points A to C on that line segment. We're going to use those and apply those postulates and our properties along with the theorems from Tuesday to practice some proofs.